0.25 compound interest formula. So part of the reading in this section, they had a couple of terms like APR and APY. All right, so APR, that is the annual percentage rate. Okay, and that's the rate that you're quoted. It's all called the nominal rate, the rate that they state for a loan or interest on a savings account or any other investment, right? And it can be compounded, right? So you can take that rate and whatever investment loan is can be compounded quarterly or monthly or weekly or whatever, right? And so different banks have the savings account, right, that are compounded differently, or CDs, maybe one bank has a compounded daily, another one has CDs compounded monthly, but they had the same APR rate. Like, how do you know, like, which one has a better rate or how much better it is, right? So this is like the quoted rate. Then they have this, and you'll see like two rates when banks advertise, and they're required to put this in here. It's called the APY, right? This is the annual percentage yield. Or sometimes you'll hear it called the effective annual rate, okay? So they'll list the APR and then they'll list an APY. And on any loan documents you get when you take out a loan, there's a, they have, and we'll get to this later, but these truth in lending statements are required. They're required to have the APY, the annual percentage yield, which is going to be a little different than the rate. And the reason is the APY is like the equivalent simple interest that you would be paying, right? And so it like eliminates any different compounding periods. That makes sense, right? So then you can compare rates. If you look at the APY of one bank and the APY of another, you can compare them directly, okay? So it allows comparisons between banks with different compounding periods. Allows comparisons between banks with different compounding periods. Or just put different compounding. Right, so that way you can compare them competitively directly, right? You don't have to sit and figure out, okay, this one's got a rate of, 5.03 compounded quarterly, but the other bank only has an APR of 5.01, but they're compounded monthly. Which one's better, right? So they have this APY, so you can directly compare the two. It's got a little fun. It's pretty simple, but we'll get to that part later. We'll get directly to the formula for APY, which probably should be something goes on your note card, right? But let's take a look at example one. We're going to derive this compound interest formula, okay? And we're going to do this on the handout, which is, the handout is like a copy of what they have in the book there on that page. So let's see, handout, okay? Because we don't want to keep doing simple interest over and over again. That just got other things to do with our lives, I would think. So let's go to this here, example one. This guy here, Jose, and maybe you put this will be on the top so if you misplace it, you know where it went, right? Jose opens a savings account with a particular principal, P, right? No, it doesn't matter right now. And it pays 2% interest, right? But we're going to use 0.02 in our calculation, right? Compounded how often? Okay, how many times a year is that? 4 times, right? So every 3 months. So what will his ending balance be after 1 year? So we're going to work this out just for 1 year, right, to get a baseline on where this leads us, okay? And so we're going to use simple interest, okay? I equals PRT. We're going to use that, and we're going to do it repetitively here. And by the time we get done, we're going to start to see a particular thing blossom here, a particular formula. Because, you know, it's worth knowing that these formulas don't come out of thin air, right? Some guy wasn't just sitting in the bathtub one night. Oh, hey, I think I'll just use this for no good reason. Okay? So, define the interest, right? So the interest is whatever his principal is, PRT, right? Times our rate, times y 1/4. Right, 1/4 of a year, okay? So 1/4 of a year. But then they simplify that, right? 0.02 times 1/4, isn't that the equivalent of 0.02 over 4 times P? So that's the interest he makes, right? He started with some principal, and he earned that much interest right here. Okay, so he made this much interest. Well, how do we find his new balance if that's the interest he earned? Right, well, whatever it is, what do you do with the interest that you get to find the new balance? Just add it to it, right? Like if you earn $1 in interest, whatever P is P plus, right? Principal plus interest. So B1, so his first balance, right? At the end of the first quarter, we're going to call that B1, right? And here it is whatever his principal is, plus this is the interest he earned, right? We don't need to know what P is right now at the moment, which means we don't have the actual interest amount, but this is, you know, in this format, okay? All right. So now, oh, what do they do here, by the way? How do they go from this to this? From algebra. Is there something common between both of these terms? Okay, so what did they do here? They factored out a P, right? The common factor. Easy, Carly. Just factoring out the letter P. And you do your best. Thank you for your efforts. Okay. So here's the balance, right? So, right, you see where this came from. So here's the balance after the first quarter. It's P times 1 plus 0.02 divided by 4. Okay, you with me? Well, now that balance here, doesn't that become the balance for the next quarter, right? And we're going to do simple interest again, aren't we? So the second quarter balance, again, principal plus interest, right? B2 is going to be whatever balance 1 is, plus this is our PRT, right? So this again is principal plus the interest on that principal, right? This is the PRT simplified, right? So you can stop me if I lose you at all, okay? That's principal plus the interest on that new principal. Okay? You guys understand that this is PR times T, right? Okay? They just kind of skipped that step. Okay. But is there a common factor here? So why don't we just factor out the B1? Okay? Okay, now here's the gist of it, right? Here's the catch. So they factored out this B1, right? But we already know B1 equals something up here, don't we? What does B1 actually equal? This, right? So you see that B1 there? Could I substitute with this? Right? So that B1, I could plug in this thing. I could substitute. So instead of B1, I'm going to have P times 1 plus 0.02 over 4, right? And on the next page, I do that. So you're with me right now, right? So my balance 2 includes a balance 1, the first balance, but I'm going to substitute what I had for B1 up there. Okay, so look on the next page. So here it is, right? This was the B1, right? And what it was equal, I substituted it in. You with me? But now, you see these two things are the same being multiplied? I can square it. I can just write it as something squared, right? So look here. This here becomes that squared. You with me? So that's my balance 2. If I've lost you, stop me, okay? All right, let's find our third balance, right? So now we're going to earn interest on this second balance, right? So here's our, again, our principal plus the interest on that principal. You with me? We're going to start to see a pattern here. So we got B3 is B2 plus 0.02 over 4 times B2. What should we do with this? Do we have a common factor again? Yeah, so why don't we factor out the B2? So factor it. Okay? But now we're like repeating things. It's like an algorithm. Do we have something that B2 is equal to from before? Up here. But now it's squared, right? So this B2, could that just be substituted here? Does that make sense? If it's equal to something, you can always substitute it in. And so here it is. After I've substituted, there that is, right? So that's that thing squared. But then times this very same thing again, right? So that makes it to the what power? This all becomes that to the third power. Are you starting to see the pattern? You just keep circling back around. And then finally, the fourth balance for the fourth quarter, right, is going to be this plus its interest. And they kind of simplified it up here, right? So now B4, yippers, here we go. B4 is going to equal principal plus the interest on that new principal, right? Because we keep adding to it. And then it looks like they just factored it out again, right? Right? Factored out the B3. But again, is there something that B3 equals that we can sub in here? Here's what B3 equals, but that time it's to the third power, right? And so look here. So that B3 is here now, right? So that's this mess to the third power times that mess again, which makes it P times what? That mess to the what? To the fourth power. You kind of see how that pattern goes there? That's how formulas get derived in that. So that's not like the complete formula, right? So the important thing here is this is just after 1 year, okay? Quarterly compounding. We'll use the simple interest to get there over and over again, okay? So basically, what do you see here? How many, it was compounded quarterly, right? Do you see some numbers in here that would reflect quarterly compounding? What number in this thing here would reflect quarterly compounding? The 4, and the 4 in the exponent, right? So it looks like the rate got divided by 4, right? And this whole thing of interest got put to the fourth power. That makes some sense to you? Okay. Now, after 1 year, that means like T for time is just going to be 1. So you could almost think of this up here as being 4 times 1 up top, just for 1 year. So maybe you remember there's a T that goes up there because you did this stuff in algebra, right? So that's kind of, does that kind of look like the compound interest formula you might remember? Right? You kind of see, I'm not, maybe you can't replicate the whole thing if you had to right now, but at least you get the idea where it comes from, right? I'm not going to put it on a test and make you do this derivation here, okay? So, but I wanted you to see it, okay? Well, now we can use this, I think, to do the check for that example.
What would I call something? B is P
we're gonna get, in just a minute, I'm gonna get the whole thing exactly the way it's supposed to go, okay? I'm gonna define all the variables, okay? So hold tight on that. All right, so let's go back to example 1. I want you guys to look at the check, okay? So I want you to use this format for the check, okay? So I can go back to this in your notebook, whoops, okay? So for the check for this example 1, just use example 1 format that we derived. All right. What's the check say? We're going to it's got $800. So that would be what part of what we just derived? The 800. What part of that thing? The P. The rate. Careful the rate, right? And importantly, our thing was only for 1 year, that right? And they only want it for 1 year. Okay. So see if you can work out the check using what we just derived. When you guys, everyone, hold two of you. Okay. See if you can find his ending balance without having to go through new simple interest using that format we just set up. Get a balance?
I thought it was 1 plus.
Oh, good for you. I'm sorry. Sorry. Yeah, you're right. Got me. 1 plus 0.0187 over 4 to the 4. Now let's try it. You got it? Oh, yeah, 2 decimals. Well, I tell you what, I want to go to your bank, man. Instead of 1.87, man, you're gonna accidentally pay me 18.7%. I'm coming to your bank every day with all my money in there. Get up, Mercedes?
Where do you get the 1 plus?
From the thing, this, we just derived that. Right there. Right? That was the whole thing we just went through. Okay. What'd you get, Carly?
815.
Did you get that too, say? 815.07? So $815.07, and that is the balance at the end of 1 year in that account. We put in $800. Okay? And we'll get to an actual regular formula for any number of years in a minute. We really don't have to add one little thing into that to do it. Okay? Let's take a quick look at example 2. I think they want us to do something algebraically in example 2, in a general sense. And again, we're going to use that format we just worked out for example 2. So if you deposit P dollars, easy for like for 1 year, 1 year again, at 2.3% compounded daily. Express the ending balance algebra. Well, yeah, there's nothing else we can do, right? Because we don't know what the principal is. So we're going to use that format. So it's compounded how often? Okay. So some principal times 1 plus, what's the rate? 2.3. So what goes here? 0.023. Okay, so now divided by what? 365. Can you imagine doing simple interest with that? To the what power? 365th power. Okay? And that's all there is. We don't know what the principal is, so there's not a whole lot else we can do here. We could probably simplify that stuff in the middle. But See how long it took us to do that quarterly with simple interest? Imagine it's compounded daily, and no one has developed a compound interest formula yet. It'd be a mess. Okay? All right, so doing that, you guys take a look at the check. For example, 2. Now we have a deposit. Now we have a principal. $1,200, 1.7, compounded monthly. So let's get her ending balance after 1 year. And that's the key here. We're just doing 1 year because we have a real simplified version of the formula. So we just put it in there. 12, oopsie daisy. So 1,200 times 1 plus the rate was 0.017, right? So divided by 12 to the 12th gives us 12, 20, 56. Yeah.
We have to add that back into the.
No, this is the balance, right? Remember, when we were going through with simple interest, we kept adding that interest. Remember, I kept doing principal plus interest to get a balance, right? And this thing we derived. Look, think of it this way, right? If I multiply something by 1 plus, right? If I was like, forget that exponent there because you couldn't do it, right? But if I was to like distribute that 1,200 through there, I would have 1,200 plus the interest on 1,200. You see what I mean? That's principal plus interest is factored out, okay? But technically you can't do that because there's an exponent there, right? Okay, but you kind of see what the 1 plus does, okay? And that's like simple, that's good, right? Simple interest is just I equals PRT. That only gives you the interest that your balance earns. When you use that formula to find the balance, you got to add it back to it. The formula we're about to put together is going to give you the balance, right? So like, now, if they ask you how much interest to earn, well, you use this formula to get the new balance, and then you'll have to subtract it, like, to get the amount of interest. But we'll do that. But anyway, let's take a look now, officially, at our compound interest formula, which definitely should go on a note card, right? Compound interest. Okay? It gives you a balance. Not the interest earned, right? Equals your principal times 1 plus. We're going to put R over N to the NT power. Okay? And I'll define all these variables here so we're clear. So B is going to be the ending balance at the end of some amount of time. Okay. P is going to be the principal for the starting amount. R, of course, is the annual rate. Or the stated, the nominal APR. Okay. And what do you think N is? The number of compounding periods in 1 year, right? So N is the number of compounding periods in 1 year. Okay? And then T is time in years. So that was the only change we really had to make, right? Just adding that T for different numbers of years. So that's time in years. Okay? So here is our compound interest formula. You've seen this before, right? You've used it in algebra at some point. Some version of it. Maybe they use some slightly different. I think they use like an A for amount or whatever. Or you know what else you used it for? If you remember, was exponential growth, right? With some different lettering, of course, right? It was the same thing. It's exponential growth. And if you keep adding interest and calculating new interest on the new higher amount, wouldn't that be an exponential growth pattern, right? And I love it when money grows exponentially. I would think you would too. But now we have formula. Let's go to example 3 and use it. Okay? Example 3. Carly, read example 3, would you please?
The rate deposit is 1650 for 3 years at 1%. Compounded daily. What is the ending balance?
Okay. So t equals 3. Sometimes I like to do this. Just get out all my variables that are going to be in there, right? And then we have, it's compounded daily, right? So what does that equal? 365. Right? They tell us anything else in there? Yeah, that's about all we need, isn't it? Oh, the rate. Yeah, I'm sorry. I thought I wrote that. And what's the rate? Yeah. So we're going to use 0.01 for the R. Okay. Let's figure out what the balance is. What's our ending balance? Oh, in 3 years. Okay. Yep. Okay. So balance. Let's just plug in our variables, right? 1650 times 1 plus 0.01 over 365 to the 365 times 3. Now we can start doing other than 1 year. So why don't you guys push button to make sure you enter it carefully, right? Make sure both of those things are up in the, like some calculators, when you go up to the exponent and you type one number in, it doesn't stay up there, so you might have to use parentheses. But and you should get $1,700.25. Make sure you can do that. After 3 years. Did we get that?
Yes.
Okay. Let's double check and do the check. And if you don't want to write out your variables, that's up to you, right? I always learn to do that, like in science classes, especially when in physics or whatever, the problems got really complicated. I just remember, okay, I'll remember what equals plug and chug after that, right? Yeah, right. Get your brain matter out on the paper. Exactly, that's what you're doing. Well, metaphorically, of course. It would. That's why we use pencil. And if we spill the wrong brain matter, we can erase that brain matter, metaphorically. Well, so I guess if we continue the metaphor, the eraser is kind of like a shot vac.
Yeah.
What? Your brain all over the place. Where's my shot vac? What's our brain material laying here? Damn kids. Clean up after yourself. Not only that, it's Legos I'm stepping on. All right, find a balance in the check there. In the check for example 3?
No, we just have to write down the
Kate deposits $1 1.1 monthly. What is our ending balance after 5 years? You're looking at the wrong one.
What? I'm not even looking at that. Oh, wait, I was looking at the extent.
Oh, yeah, just the check part. We're going to skip the extent part. There you go. Now you're on it.
I was looking at the bright red thing.
Ah, yes.
Right. I was over here in the check for an example 4. I was like, what? What's up, bro?
All right. Tell us what you get.
$40,482.
4482.81. I agree. Easy enough. Now we have a formula. That would have been a lot of, so look at 5 years compounded monthly. You imagine how many times we would have had to go through and do simple interest for every month for 5 years? It would be 60 times. I think not. That's why we got to maths. Right? Maths makes life easier.
Yeah. I wish you gave it to us earlier.
I'm giving it to you now. All right, let's go to all right, before we do example 4, I think it's the APY one. Yes. So let me give you so the APY, a little more info on that before we get to example 4, right? Annual percentage yield, right? So APY, that's like the simple interest. Come on. Equivalent of APR. Okay? So APY is like, okay, that's your APR, but to get to that ending balance using simple interest with no compounding, what would that rate be? And that's the one, yeah, you can compare it from bank to bank because they're all required to list an APY with their APR. Okay? And all we have to do is take the amount of interest they earned in 1 year, right? Divide it by what they originally had in there and multiply by 100. That's it, right? So APY equals their interest divided by the original principal times 100. Okay? And this is just for 1 year. You look at 1 year.
Wait, so when you subtract, for example, like
Right.
ending balance.
Yeah. So you use that formula, right, with the APR, get that ending balance, right? Then you've got to subtract, okay, how much more is it than the principal? And that's the interest divided by the original interest, right? So that's like numerator sold over whole, isn't it? Right? Interest.
APR just I equals PRG.
No, that's a simple interest formula. APR is not a formula, it's just a rate that the bank says, okay.
Oh.
It's an annual percentage rate, and that's the part of it. Right. All right, so knowing that, let's look at example 4. Mercedes, read example 4, would you?
Share deposits $8,000 year CD at 2% interest compounded daily. What is share's annual percentage yield APY to the nearest hundredth of 8%?
Okay, so maybe another bank pays 2.3% interest, but only compounded quarterly. And so you go, wait, which one's going to pay me more interest, right? But they have to list this APY. So let's figure out what their ending balance is with that compound interest daily, right? Subtract it and then get the APY. So let's do her balance for 1 year. Okay? Remember, APY is based on 1 year's worth of interest. Okay? So balance. She put in 800, right? Times. Am I looking at the wrong one? 8,000. 8,000 times 1 plus 0.02, right? Over 365 to the 365, technically times 1, right? So what did you get? 8161.61. Okay? So that's your ending balance after 1 year. All right, let's get the AP, or the actual effective yield, if it was simple interest. Well, this is pretty simple. How much interest did she earn? You do that in your head, right? So her interest that she earned in 1 year is 161.61. Well, so in other words, we're asking this 161.61, what percentage of her original balance was it? And that's your simple interest, APY. So her, and that's right, percentage, right? So her APY is just gonna be that over her original deposit times 100. And they wanted the how many decimals? I think 2. Is that? Well, yeah, okay. 2.02%. All right. So what was the APR? The APR was 2%. Right? So they say, yeah, come on in, we got an APR of 2%. But you see the yield is a little bit higher than the stated rate, the nominal rate. You know what nominal means, right? Like in name. All right. Does that make sense? APY. And again, all banks are required for their loans and their deposit accounts to list their rate that they use in their calculation. But then to offset the compounding, they have to also list an APY. Right? Let's try the check with that. Let's see if you guys get this. 3,000 1-year CD 1.1%. What's the APY? Okay, so you got to find her balance after 1 year. Use compound interest, and then figure out what percent of the original balance that interest is that she earned. Okay, so you guys take a minute and see if you can work that through.
I got 30, 30, not 30, 30.
Oh, it's 30.33, isn't it? What'd you get, Mercedes?
30.33.
Yeah. Yep. Yeah, double check it. Equals $3,000. 1 plus 0.011 over 365 to the 365 times 1. 303,318. So our interest amount is just 33.18, right? Okay. So I should write that for APR here. Would be is 1.1. What'd you get?
1.12%.
1.112 or 1.1?
I got 1.1. Oops.
Yeah, please remember. Yep. Okay. So for APY is going to be that over the original times 100, 1.11%. Okay. So they'll list an APR of 1.1 and an APY of 1.11. And that's how you compare to any other bank. Maybe another bank has the same rate but different compounding. Or slightly different rate but different compounding. It avoids confusion. You got the hang of that? Okay, so now we have a compound interest formula. You know how to find the APY, sometimes known as the effective annual rate. Okay? Effective meaning disregarding compounding, right? Simple interest rate is the APY. And there you have it. And you actually derived the formula used all over the world for many, many centuries. You guys derived it. That's what you are.
So,
Yes.
did you guys